Okay, in this video we're going to look at APs, so recognize and sum a finite arithmetic series. The first example we look at is, for example 1, for the following AP, state A and D and find the 10th term, U10. And the sequence is -2, 4, 10. Okay, so we'll just take a look at that. We're given -2, 4, and then 10. So the first term we're asked is always given by the letter A. And in this case, the first term is -2. And D is the common difference. So 4 minus -2 is 6, and we just check that is the same as 10 minus 4. So D is indeed 6. And we're asked also to find the 10th term, U10. So we know from our formula that should be A is -2 plus n minus 1, that's 9, times D is 6. So 9 sixes are 54, -2 is 52. So that's the first example complete. U10 is 52. Let's take a look at another example now. Example 2. We're told that the sum of the AP SN is 2,660 and the AP is given by 8 plus 11 plus 14, and we're asked to find how many terms are there. Okay, so let's take a look at this example. So we're just going to start with, we're told the sum SN is 2,660, and we're given the AP 8, 11, we're summing these, 8, 11, 14. Okay, as in all APs, let's start by writing the value of A. A is 8, and then the value of D. So 11 minus 8 is 3, and that does equal to 14 minus 11. And we're told SN equals 2,660, find N. So let's just pop everything we have into SN. The formula for the sum of an AP is N over 2. We don't know N, but we do know A, 2 times A, plus N minus 1 times D. D is 3. I'm going to simplify this until we have an equation in N. We can set it equal to 2,660. So we have, I'll maybe multiply across by the 2. Well, let's do first N over 2 times 16 plus 3n minus 3 equals 2,660. And so we have n over 2 on 13 plus 3n equals 2,660. Now let's see if we can solve this one. And so we will end up with a quadratic equation 3n squared plus 13n equals 5 320. It's going to give us a strange quadratic equation. Let's just see if we can solve that quadratic using the calculator. So we'll look at mode 5 quadratic equation 3. So we have a equals 3, 13, and minus 5, 3, 2, 40. Okay, so we're given two solutions here when we look at solving the quadratic. So 313 and minus 5300. So we are given solutions. X1 equals 40. So n could be 40, or n could be a negative 133 over 3. So we have to reject the negative and leave the n equals 40. Now, if I try to solve that, obviously in an exam, I wouldn't be using the calculator to solve the quadratic, but here it's kind of handy. So n equals 40. Okay, let's take a look at the third and final example. Example 3. So find the sum of the following AP. So we have negative 6, negative 4, negative 2, and so on. And let's just skip across and do that example. We have negative 6, negative 4, negative 2, all the way along until we get to positive 92. So we have to sum this AP. So we need to find Sn. So we need to look at the term 92. So if Un equals 92, we need to find n. So again, we'll state A is negative 6 and D is positive 2. So Un equals minus 6 plus n minus 1 times D, and we're told that equals 92. So we've got negative 6 plus 2n minus 2 equals 92. So we'll have 2n on the left equals 92 plus 8 is 100. N equals 50. So we need to find the sum of the series Sn when n is 50. So 50 over 2 times 2a times negative 12. I'll just do that again and move it down. So n is 50, S50 equals 50 over 2. 2 times a is minus 12 plus 49 times 2. And we can simplify that. It's 98 minus 12. So we've got 25, and inside here it becomes 86, and final answer will be 2,150. That's the final answer. Okay, that's all for this video, and thanks for watching.